Welcome to this video. In this video, we want to continue where we ended on the topic of bearing. In the previous video, I introduced you to Morton's 5 rules of bearing. In this video, it will actually concentrate on the examples. Let's see the examples and enjoy the beauty of bearing, which is being added into the mathematical world. Hello, bearing. The question reads, from the diagram below, find the bearing of L from M. So we are looking for the bearing of L from M. This is our first question. So this is our L, this is our M, this is our N. N means your north, which is your true north. So the bearing of L from M, rule number 1, Morton's rules of bearing, rule number 1, go to M. When you go to M, this is our M. When you go to M, what must you do? Rule number 2, make your true north. Draw your true north. So I'm going to draw my north. This is my north. This is my north. Okay? So when you make your true north, rule number 3, move clockwise direction starting from your true north. Move clockwise direction. So starting from this true north, move clockwise direction. So this is clockwise direction. As you're moving clockwise direction, rule number 4 says end at the connecting line. In this case, the connecting line is line LM. Line LM is this line. So as you are moving, end at line LM. Okay. And then the last rules, Morton's rules of bearing. The last rule, which is the 5th rule, is the direction covered or the angle covered is the bearing needed. So this angle which has been covered is the bearing which we are looking for. So how can we know the value of this bearing? There are a number of ways in which we can calculate it. Number of ways. You know, I hope you have understood the previous video which I've explained about the types of angles, the alternate angles. In here, this is where they are going to work. For example, this angle is a reflex angle. So I know that this angle is more than 180, but is less than 360 degrees. So how can I calculate it? Very simple. Watch and learn. All right. So this is a true north. This is a true north. This is a north. This is a north. In short, I can even make this one go down here like this. So these norths are actually parallel to each other. They are parallel to each other. And I've got this line here, which is crossing these two parallel lines. It's taking us where? To alternate angles. Why did I explain about alternate angles? These opposite angles are what? Are equal. So meaning that this is 112, and even here, from here up to here, this is 112. From here up to here. But on the types of angles, I said an angle that is starting from here up to here has got a special name as what? A straight angle. This straight angle add up to what? 180. This is 180. Therefore, for me to know the angle from here up to here, I'll then add. I'll say 180 plus 112. So we add, this is 2, this is 9, this is 2. So the bearing of L from M is what? 292, which is 292 degrees. Very simple concept there. If I tell you don't want to use this method, there is also another method which you can enjoy it. Which method is that? We can look for the angle which is here, first of all. We can look for the angle which is here, of which in the previous video I already told you how to calculate these types of angles. All right. So for us to find this angle here, remember this is a straight line. So let's assume that this is our x. This is our x. So meaning that if we say x plus 112 should be equal to what? 180, because this is a straight line. When you correct the like terms, you're going to have x is equal to 180 minus 112. Okay, so 180 minus 112, what is our answer? Let's subtract. Simple subtraction here. So 0 minus 2, it's can't. We take 1 from here, we put it here. 10 minus 2 is 8. 7 minus 1 is 6. So giving us what is 68. So meaning that x is what? 68. So here we have got a 68. If this is a 68, under the properties of alternate angles, we say this angle is equal to this angle here. Then if in here it's what? 68. Okay. So after knowing that, we have got this scenario here. Watch what we are having. Okay. This is our n. This n is this. Okay. Then this is m. This is the l. Like this. Then this is 68. And then we are looking for this angle here. Have you seen this angle here? Of which we know that the total sum, the complete revolution is what? Is 360 degrees minus, let's remove the 68 degrees. When we remove it, we're going to remain with the angle covered there. Very simple mathematics. The beauty of numbers, which is meant to be enjoyed but not to be hated. Okay, so we're going to put 68 here. And then we subtract, of course. Okay, so here it's can't we know from here, so we get our 1. Then we say 10 minus 8 is 2. And then here again it can't, we do this. And then 15 minus 6 is what? 9. And then we have 292, which is the same answer with this answer here. Very simple concept of bearing there. So here I've used the rules, the Motors 5 rules of bearing, and I've also used the concept which we learned in the previous video. So in this first question, I've explained different ways in which you can calculate the bearing. So in this other, you're just going to dance with them direct, right? Direct. Okay. So now, we are looking for the bearing of L from M. Okay. So this is our L. M is supposed to be here. Okay. Like that. So this is L. This is M. Okay. So now, to find the bearing, what must we do? First, through Motors 5 rule of bearing, go to M. When you go to M, make your true north. As you can see in this case, this is our M, this is the north. As I said previously, in the previous video, I said that sometimes a true north might be drawn onto you. In this case, we have a true north already. So this is our true north. So when you have got your true north, move clockwise direction starting from your true north and end at the connecting line, which is line LM. So the angle covered or the direction covered is the bearing needed. So remember that for you to calculate now this angle, we know that the complete revolution is what? It's 360. It's 360 minus what? This 40. When you subtract, you are going to have what? 320 degrees. So 320 degrees. So this is the bearing for question 2. Very simple concept there. Let's go to our last example there. The bearing of L from M. Where should I put L? Where should I put M? The beauty of math. Math is a simple subject on this planet Earth. I can put it anywhere. So in this case, let me just rotate it. Let me put my M to be here and my L to be here. So now we are looking for the bearing of L from M. The bearing of L from M. Okay. What must you do? We go to M, move clockwise direction, starting from your true north. We already have a true north, end at the connecting line. This is line LM. So this angle is a bearing needed. So we know that this angle is equal to this angle. For us to find this angle, we subtract 180 and what? 30 degrees. So we say 180 minus 30 degrees, which is 150. So this is 150 degrees. So this angle is alternate to this angle, meaning that even here it's 150. Therefore, the bearing is what? It's 150 degrees, which is 150 degrees. Very simple concept of bearing there. If let's assume your question was, this is a line, and then this is my M, this is my L, and then they're looking for the bearing of L from M. The bearing of L, sorry, the bearing of M from L, like this. What you must do is go to M. Go to M and use the Newton's 5 rules of bearing. Then you make your mathematical word to be simple. As far as bearing is concerned, in this video, we have come to an end of bearing, the topic bearing. Hope you have followed me from the first video up to this very video. If at all you have got any challenge or any questions as you are watching this video on YouTube, please kindly forward your question below down there and I'll be there to respond to you. Preferably, you can also get in touch with me through a call or a WhatsApp message to the line which is going to come immediately after the end of this video. The end.